Hi, welcome to the Olympiad geometry. Let's continue our study. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe to the channel. So today we're going to talk about a problem, which is the XMO. It's from 1974 IMO long list. Outside an arbitrary triangle ABC, triangles ADB and BCE are constructed such that we have conditions. So let's just draw an arbitrary triangle first. We have triangle ABC here. And we know that we want to construct two triangles. One is ADB. So you can think about ADB is here. And we have to satisfy the conditions that angle ADB equals to 90 degrees, which means that the triangle ADB is a right triangle and angle DAB equals to 30 degrees. So we find 30 degrees here first, and then find 90 degrees here. So we know this one is 30 degrees. And also we want to construct the triangle BCE, that angle BEC equals to 90 degrees, right? So angle BEC is 90 degrees, and angle EBC equals to 30 degrees as well, which means we can do things like this, right? And we know this is 30 degrees. On the segment AC, the point F with AF equals to 3 times of FC is chosen. So that means this is a midpoint of AC, then we know this is F, right? The midpoint, this is a quarter point of AC, so that we have AF equals to 3 times of FC. Now we want to prove that angle DFE equals to 90 degrees. We want to prove angle DFE equals 90 degrees and angle FDE equals to 30 degrees. So what's the key point of, or what's the break point of this problem? Right, that's a question. The first thing that we notice here is that we have this 30 degree and right triangle. So we know that DB is half of AB, and we know CE is half of CB. But we cannot really use that condition to get any further result. Then the question is that why we want to choose this very specific point F, right? This point F satisfies that AF to FC equals to 3. So this number should remind us, if we can just find the projection point here from D to AB, let's call this point as T, for example. Right? In this triangle, we have these 3 included. Why? Because we know that triangle ADB is a right triangle which has an angle as 30 degrees. So we know that DA is square 3 by 2 of AB, right? That is saying, if you look at the triangle ADT and triangle BDT, it's similar to triangle ADT is similar to triangle DBT, right? So we know that BT equals to half of DB equals to half of the DB equals to half of AB. So it equals to 1/4 of AB, which means BT to AB equals to 124 equals to CF to AC. So we know that TF is in parallel with BC. Right? We know that TF is in parallel with BC. And we know that the angle, let's see it this way. Look, TF is in parallel with BC, and if we calculate for DT to DB, right? DT to DB equals to square 3 to 2. That's DT to DB. And also, if we look at TF to BE equals to TF to BC times BC to BE, which equals to TF to BC, that is 3 to 4 times BC to BE, that is 2 to square 3, which is square 3 by 2, which means that DT to DB equals to TF to BE, right? And also, because this angle, the angle ATF equals to angle ABC. And we know this is 90 degrees, this is 30 degrees, this is 60 degrees. So the angle DBE equals to angle DTF, right? Therefore, we get TF to BE equals to DT to DB, and angle DBE equals to angle DTF. So we know that triangle DTF is similar to triangle DBE, which means the angle BDE equals to angle TDF, which means angle DBT equals to angle EDF, right? We know that this triangle is similar to this triangle, so this angle, this one, equals to this one. Then this angle equals to this angle. And we know that the angle BDT is 30 degrees, so the angle EDF is 30 degrees. Right? We know that angle, now we know that angle EDF is 30 degrees. Now the question is, so we proved this part. Now the question is, how can we prove angle DFE is 90 degrees? Look at what we get here. We know that triangle DTF is similar to triangle DBE, right? So DF to DE, DF to DE equals to DT to DB, right? DF to DE equals to DT to DB. And because the angle DBT equals to angle EDF, so we know that triangle EDF is similar to triangle BDT, which means angle DFE equals to angle DTB equals to 90 degrees. Right? So this problem is not that difficult. It's just we need to find the proper auxiliary line, and that requires some sensitivity on this special point, right? When we see that this F is specifically chosen, remember that a triangle ABC is an arbitrary triangle, and F is specifically chosen to be a quarter point, which means that this 3 means something, right? This is not an arbitrary number. This 3 means something. And the 3 can relate to the triangle ADB or triangle BEC, right? The triangle in triangle ADB, the only 3, the 3 terms only come to the ratio of AD to AB or AD to DB, right? Then we have to think about how can we really get this 3 to be useful. Then we can think about try to find this T point and check on the relation. And then the problem becomes very easy to solve because of the similarity of the triangles. Okay? I hope you like this video. See you in next one. Thank you.